welcome to episode number 34 of this Amiga assembly programming series based on the book of Fabio Ciucci, who I thank, as always, for giving me this possibility to stream his book. If you recall, last time I was saying, okay, that before we take control of the Blitter, okay, we need to check that the Blitter is available, it's not doing anything, okay, because if you try to start setting it up to do a Blit, while it is doing something, when it's doing a Blit itself, then we will have an issue and you will cause probably a guru. Please note, as I mentioned, and it is highlighted in red here, that the first few Amigas had a bug, and because of that bug, you will need to read the register DFF002 bit 6 to test for it twice, and then of course continue doing a loop to make sure that it is fine. So I will be showing this how to do it, but just keep in mind that because of the bug we will need to do it twice the first time we read it. Now we're going to talk about 4 steps to do a Blit, and this is very high level, okay, but it should start giving you an idea of what is required. For every Blit we can enable and disable the channels that we want. So I already told you that there are 4 channels named A, B, C, and D. A, B, and C are for reading, D is for writing. So as you can see here, 3 are source, 1 is destination. The destination is always needed, the source is not always, and you will see an example in a minute where we will just use the destination without any source. We need to make sure that anything that we don't use, we put at 0, okay, in it. This is because the Blitter from OCS to ECS passed through some versions, and because of that some bits might mean differently on a different machine. So the best way, and to be sure, is to always set them 0. Of course, if we write 0 to the DMA channels, then they are disabled. So if we just want the A and D, for example, and we need to write 0 into the B and C. I will be showing you how to do this later on. Right now you need to accept certain values because there's some settings that we need to set up, and I will not be covering them all in one go. You just need to get used to the fact that some values are like that, and then they will be explained. Basically, the bits that we are interested in for setting the channels are from 8 to 11, and as you can see, 8 to 11 are what we need to enable the channels that we need to enable in register DFF040, which is Blit con 0. The second term, and this will be explained later, and it is done in red intentionally, is what is called min terms. This is to tell the Blitter what operation we want to perform. For now, accept the values that I will be giving you in terms of min terms, and then we'll explain how min terms work. It will not be today, it will be probably next week. Although before next week there's a long section about shifting. So for now, accept that the values that I give for minterms, and you do not have enough knowledge to know what minterms can be used for. So till we arrive to that point, just accept the values. So that was step 2. Step 3, every channel needs a pointer. So if we have 4 channels, each channel has got a pointer. Every channel has 2 words, because a pointer is 32-bit. Okay, it's 32 is 2 words, so it's a long word, and we can access these using the move.long. I mean, we can write to them using the move.long, and they are done in sequential. So like we do for bit planes, we can do for the Blitter, and for example register A, we have a Blit A pointer, which is 50 and 52. The first one is the high word, the second one is the low word, and you can see that A, B, C, D, you might think that they are in sequence, but they are not. C is the first one, 48, then B is the second one, A, and then D. It is done like that. Probably, this is my guessing, because A, D is always used. Then the most likely that you will use is A, channel A, then probably B, and then C. So this is why they've done them like that, starting with C, and then B, A, and then D. Also, you do not, because we're writing 32-bit address, we do not really care about the low part, because when we write, we do a move long to this address. But know that there are 2 registers, no? That's we write to them, as I was saying, in the same way we used to write for the bit plane pointers, using a move, and we do a move to DFF 050, 040C, 048, and 054. Now, the Blitter works on words. I said this last time, and I'm repeating this. Because the Blitter works on words, everything needs to be even. That means bit 0 is ignored, and it's useless trying to do odd. Always write even. So you always need to write even addresses in the Blit DMA registers. So the address needs to be an even address. Okay, so the pointer needs to be an even address. Here there's a note which I already said, and I'm going to repeat it. Make sure that bits that we don't use are set to 0. This is important. There's bits that are used in AGA that if you leave them set on if you have a model of OCS or ECS and you leave them set on, AGA can interpret it differently. So make sure that all the bits are set as required to 0. So that was step 3 in setting the pointers. Step 4 is doing the blit size. How we we want to tell the blitter, hey, this is the area that we want to blit. This is the area that we want to copy. We do this. Actually, I'm going to read my notes so that I do not skip anything in this case. So the last bit that remains is to write the length of our blit. The length or the blit is always what we read is what we write. Okay, so remember they are the same length. Okay, this is done using register DFF058, which is the blit size register. It is pointed here. Okay, this register does not permit the blitter to okay, you might be thinking that this register, when we tell the blitter to start copying, it reads a sequence of bytes or words in this case in memory, but actually it reads a block, a rectangle. So right now you cannot maybe visualize how this is done, but please note that blit size, you need to tell it how many words you need to copy horizontally and how many lines you need to copy vertically. So it has an X and a Y. Okay, the X is always in words, so every 16 bits or 16 pixels. So if we had to imagine we want to copy 8 words, okay, and they are next to each other, okay, the blitter, you still need to tell it that there is one line. So you're copying 8 words, one next to each other, and the height of that is 1. Okay, so here he's going to give us this example. We have 8 words, okay, but the height is 1, as you can see. Altezza means height. So the blitter, we need to tell it 8 words and the height is 1. Now there are many ways how to specify the width and height. Let's say we want to copy 50 words, as in this case up here. Okay, 50 words can be copied as 10 words and of a height of 5 rows. Okay, but it can also be 5 words with a height of 10. So we need to specify that what is the width and what is the height, and I'm going to show you how you specify that. But first of all, let me explain something about the blitter. So blit size, okay, is a 16-bit address register. Okay, however, this is divided in two. The first 6 bits specify the length. The rest 10 bits specify the height. Now, the 6 bits that specify the length, okay, the width, the X, okay, on the horizontal plane, remember they are words. So with 6 bits, that means we have 1024 pixels. Okay, at the same time we have 10 bits to specify the height. Okay, 10 bits is also 1024 lines. Okay, so the blitter can do 1024 pixels by 1024 lines maximum as height, and I'm talking always in a standard Amiga A500 or 600 OCS. Okay, I'm talking about OCS or ECS. So because of that, here is what all this means. Okay, horizontally it means it can read 1024 pixels, which is 128 bytes or 64 words. Okay, vertically it can have 10 bits. It has 10 bits, which means 10 bits represent 1024 lines. Hence, okay, hence 1024 times 128 is 128k. That is the maximum the Blitter can copy in one go. Okay, which is more what the biggest screens of the Amiga have at this moment in time. So, as I said, this means that the maximum Blitter rectangular block size is 1024 by 1024 pixels by 1024 lines. I hope this is clear. Note that, as I said, the register Blit size, okay, which is DFF008, is divided into 6 bits for the X and 10 bits for the height, which you will think it's complex the way to specify it, but it's very easy, and you'll see an example and you'll understand what I mean. I am not going to go to the detail of it till you see it, because it might confuse you, but just know the limitations of the Blitter right now. And remember, the Blitter always works in chip mem, nothing else. Let me see if I said everything from my notes before I say. Yeah, as I said, this is for a normal Amiga 500 machine or 600, because there was no difference when it comes to the Blitter in this case. Yes, I forgot to mention something. When you write, okay, or you tell the Blitter the width and the height, so you write to Blit size, okay, when you write to this register, that means also you're giving the command to the Blitter to start the copying process. So this is always the last instruction that you give to the Blitter. As soon as you give it, it starts writing or copying. So make sure that you set up all the settings before you specify the Blit size. Okay. So let me show you the first example. The first two examples, nothing happens to the screen, but things are processed in memory. Remember that the Blitter, it doesn't care. It just needs to copy. And copying means whatever the data is. So because we're copying from one memory to another, which doesn't happen to be on the screen, we will see things happening in memory. Okay? So let me switch you to the Amiga. I need to start the assembler. Normally it is started, but today I have to start it. So first of all, let me explain to you what I meant by specifying the Blit size. So here I'm specifying the Blit size. I'm saying we want to copy 16 words. Remember, that is hex. 16 words of a height of 1. So what you do is you specify the X in words, and then you specify the Y by multiplying it by 64, because this is where the bits are in that. Is how you can do it in the assembler. So if you want one line, you do 1 times 64 plus the width. Basically, it's easier to see it like that and how you can specify it than bringing the register and trying to calculate it in a complex way. So this is why I'm showing it and why I told you it's better if you see it in the example. So let me show you what this program does, and then we will go through it bit by bit. So let's assemble. I'm going to show you the memory. Okay, so we have a block of memory which is filled with FEs. Okay, and then it's only 16 blocks. Sorry, 32 bytes. Okay, each line is 16. That we will be copying. So we are also going to use one register, one channel, which is the D channel. By using just the D channel, we are telling the Amiga that we want to zero the memory where we are copying. So if I execute it and then do mstart, you're going to see that the memory now is 0. Okay. Now, let me start explaining to you how this magic happened. So let's go to the book. So this is the code that we had. Of course, here we are just taking control of from the OS. Then we are telling the OS, hey, we want the Blitter and we want to own it. This is a system call which says we want to own the Blitter. Okay, that's why it says own Blitter. Then this part, okay, let me see if it lets me select it. It doesn't. Anyway, these two lines, as you can see, this one, we do it because there's the bug, as I told you, in the Amiga and the first Amigas, okay? Then we do a loop to test that the Blitter has finished doing its operation. We always need to do this test. We always need to do this loop of testing that the Blitter is not being used before we start doing anything to it. Even if we are just setting the registers. If you're setting the registers, that means you are affecting the Blitter if it's doing something at that moment in time. So you need to always make sure that the Blitter has stopped doing what it needed to do before you can do any settings to it. Now, as I said, minterms are not explained yet. So please accept the value of 0, 0, okay, in the minterm, okay? It's from bit 0 to 7, the minterms, okay? The other is we're selecting channel, the D channel, but I will come later of how to specify this. But just note that so far that is the value that we have selected. This register is also going to be explained later on, BlitCon1, so just accept that it needs to be 0 for now. Then we are using only the D channel, so we need to tell it the pointer where we want to make the copy 0. Make the Blitter to set the memory to 0. If we are using the D channel only, normally use the D channel only so that you can clear the memory. The Blitter can clear the memory faster than the 68,000. always talking on a standard Amiga. Then we haven't covered this. I can tell you this is the modulo like we have for the bit planes, but there is something more to it. So it will be explained later. Then this is the blit size, which I explained a minute ago. You specify the height times 64. Okay, you always have to do that. And then add the width. And remember, the width is in words. Here we are zeroing 16 words. Once we tell the blitter to start executing, because we used blit size, as soon as we use blit size, the blitter starts writing. We need to start testing if the blitter has finished. And this is our testing part. And remember, we still need to read it once and then loop, and then do the loop. Once we finish, once the blitter has finished, then we can tell we don't need it anymore. So we can give it back to the OS. So we use the system call disown blitter. Okay, and then we return to the OS. This code is still not using the startup file yet, but because it's a simple example, there is no need to use the startup file. Eventually, you're going to start seeing the startup file. So, as you saw, we had a block of memory, 32 bytes, filled with FE, okay? And we managed to turn these using the blitter to 0, okay? We, as I said, we are only using the D channel here, and the min term is 0, hence we are filling the memory with 0. I will come to this more later, so please, as I said, accept what I'm saying. Now, if you recall, okay, if you recall lesson 2F, okay, we had written a routine, okay, how to clear the memory using the CPU. This example is the same as that one, but using the blitter. Instead of using CLR to clear the memory, we are using the blitter to do the same job. No difference, just we told the blitter to do it for us. The clear operation only requires the channel, okay? Also, all min terms need to be 0, so that's why I said it's 0, and we just need the D channel. So the value that we need to set in blit BTL con 0 is 100 hex. Here he is explaining what I showed you better in the code, how to specify the blit size, but basically you specify the height times 64 plus the x in words, remember. I believe we need to do also this one. Let me see. Yeah. So we did this and we did this. Let me see if I had any notes in relation to that or this one. Now we are going to use the A channel and the D channel, and we're copy from a memory location to another memory location. And this time we're going to use the blitter again. So we are going to use 2 channels now, not 1, as we did before. So let's switch to the Amiga and I show you. So if I do M sort, I think this is the sort, and we have these values, okay? Then if I do mdest, this is the destination, and as you can see, it's all zeros. So now if I do j, okay, and I do mdest, we should start seeing the same thing as we had in the source. So we copied from one place of memory to another. So let's go back to the book. We are still not using the startup file, so this is exactly as before. We're taking control of the OS we also want the Blitter for ourselves, and we are using the test to check that the Blitter is free and we can use it. Here is our Blit. This is the code that we are interested in. The rest, what's down here, is the same as we had before. So blitcon 0, we are telling it that we are using minterm f0. Okay, this is for copying using source A to source D to destination D. Okay, and the 90 is the channels that we are using. As I said, register 42, just accept that needs to be 0 for now. It will be explained later. Now, before we had only one register that we needed to set the pointers. Now we have two, because one is source, the other one is destination. Notice the move long, one is for the source and one is for this destination, and sorg and dest are down below. Okay, this is sorg, and we are copying what we have here to dest, which is down here. Okay, now because we are using two channels, we also need to set the modulo, okay, of the two channels A and D, as you can see here. In this case it is 0, and as I said, accept that it is 0. Modulus will be explained today later on. Also, we are copying a block of 16 words. So the height is 1. So 1 times 64 plus 10, that is our blit size. Once we write to the blit size register, the blitter starts executing. While it is executing, we do our test. Okay, this part that so that we make sure that the blitter has finished doing what it needed to do, and then we can close and return everything to the OS. Remember the first line. I'm repeating this because I personally didn't know about this bug 30 years ago. So I was ignoring this part, the first bit. So the bit BTST, bit 6 on the F2, you need to do it before you enter the loop so that the blitter bug can be bypassed. I believe there's nothing else to this one. Let me see. No, that is, I showed you how to execute it. Well, this is what I explained, that we need the source and the destination. So we use channel A and B. And we need to accept that the min term is FO to copy between channel A and D. Okay, that's basically it. So those two examples didn't show anything to the screen, but they gave you an idea how you copy from one part of memory to the other, or how to clear memory. Now everything that we do, it will be on the screen. So let's continue. First application with the Blitter. So we'll start using the Blitter. We know that an image is composed of words. Okay, so an image, even though it's in memory, okay, it is composed in words for the Blitter. Let's do a simple revision of images in memory. Let's say we have a screen which is 320 pixels wide. That means we have 40 bytes as width, but that means also that we have 20 words as width. Okay, and remember, we need to think like that because we are using the Blitter. Just going to go a bit down to show you the diagram. So if we had to divide the screen in words, okay, and we said that the first one, so top upper left hand corner, okay, is the first word, is numbered 0, on the first line, okay. The end of it is 19, okay. So between 0 and 19 we have 20, okay. Yesterday I said that there's a mistake in the book, but I was corrected. There isn't. In terms, I read the Italian wrongly. However, I still have a note here that this one is 0, this one is 20, this one is 40. It's not 21, it's 20. So we start with 0. So this column is always in steps of 20s. Okay. So note that we are only interested right now, to be honest, in the X. The height of the screen is irrelevant right now, but for each 20 words we have a line, okay, of the screen, whether the screen is 256 height or 200 height for NTSC or whatever we decide that to be. So the image in memory, okay, let's say this is a bit plane, needs, or let's say is divided for the Blitter in this manner, okay. Now what he's writing up here, what he said up here, is represented down here. So I'm just going to say it, okay. If we have a 20, so we have a problem, to be honest. The problem is we cannot always have an image that is in a boundary aligned of 16 pixels. You know, in a word, we can have, I don't know, an image that is 20 pixels, no? So what happens in that case? What will happen is this: because 20 doesn't fit in one word, we use two words, okay, and the extra bits or pixels are filled with 0. Here we have 20 pixels long, so we use two words, and as you can see, we fill them with zeros. We need two words to have this type of image. So the Blitter is always aligned to in 16 in words, basically. So if our image is stored as part of our program data and we need to copy it to the screen, to see it on the screen, we need to copy in memory, copy it in memory to the area dedicated to the bit plane, and we copy it word unlined. For now, please accept, and I'm going to make an exception right now. I know that images are not always in rounded to an edge of 16, but for now, assume that everything that we will do is divisible by 16. We will come to the when we will come to when we don't have 16, when the image is not divided by 16. But for now, let's learn the theory and how it works. We will come to that at a later stage. For now, though, so as he says here, for now, let's limit ourselves that x is always in multiples of 16. Okay, so always in words. All the copying that we have spoken so far can be done with one blit. Okay. So when you have the source, when you specify the source, you give the pointer, and you give the pointer to the source, and then you give the pointer to the destination. Once the blitter starts executing, that pointer is being incremented. Okay, keep that in mind. It is, if we were at address COO, okay, let's say it becomes COO1 2, sorry, and it continues like that because it's a multiples of 2. So it's always incrementing. This is why you need to wait for the blitter to finish its operation before you go and change the registers, because if you write to a register while it is still in execution, okay, you will be affecting the blitter and you'll be confusing it. Let's keep something here. Also, for now, let's assume that the bit plane top upper left hand corner is 0. Okay, I mean, eventually we have a base address for the bit plane where it is, but for our formulas to work, let's assume we start from 0. So if we want to know, let's see before I, yeah, I'm just going to go back to this diagram. Okay, so if we want to know what is the address of 40, where 41 is, okay, we just need to do, okay, we know we start from 0 in the upper left hand corner. Okay, so, and we know that a row is 20, so what we need to do, and we are in row 3, okay, so we do it 3 times. Okay, so we start from 0, 0, 20, and 40, and then we need to know, then we need to add 1, because we are talking about 41, and that means we are 41 words from the base address of where the bit plane is. But when we specify the address, remember, we specify it in bytes. Hence, we need to multiply that by 2. Okay, and this is what he's going to explain in a minute. I just wanted to show you the diagram so that you understand what he's trying to do, because the diagram is not, it doesn't move with the book, so I have to show you that. So we need to multiply this number by 2 and add it to the base address that we have here. let's see if he, yeah. So let's start to calculate the number of the first word row y. Remember, each line is formed from 20 words. You will notice that the first word of each line starts at 0, 20, 40, 60, and it continues like that. In general, the word of a line is y times 20. So if we are on line 3, it's 3 times 20. If we are on line 0, remember we start from 0, okay? It's 0 times 20, which is 0, okay? With the same principle, if we are on line, as I said, 41, okay, then that is line 2, okay? So 2 times 20 is 40, okay, plus 1. That is what he's saying here. But so he came up with this formula, okay? Y, the height of a line, times 20 in this case, plus r. R is the distance in x, okay? And he used r for a reason, because we're going to talk in pixels now instead of words. So let's say we want we want the pixels that start at pixel 32. To do that, and I hope I am not jumping anything here. So in this case, I'm going to just take one line right now, okay? So and we are going to talk in pixels right now. So pixel 0 to 15 is the first word. Pixel 16 to 31 is the second word. Pixel 32 to 47 is the third word, etc. But remember, we start from 0, okay? And here is the formula, okay? The line where we are times 20 plus, in this case, is 0, okay? If we want 32, if we want pixel 32, then it is y times 20 plus 2. I hope this is clear. So, let me see. Here is a mistake. Or I understood the Italian incorrectly, but I am saying how it should be, okay? So to calculate the distance in words, it is only necessary to divide the pixels by 16. If the distance is 32, then the distance is 32 over 16, which is equal to 2, okay? So if we take this, whatever pixel we have, we divide it by 16, and that is the word that we need to add to this formula that we have here. That's what is he saying. So if it's 32, then it is y times 20 plus 2. And if it is 64, as he says here, then it is y times 20 plus 4, because 64 is here, and that means that y times 20 plus 4 is our word. Right now, we are talking about the horizontal position, word aligned of the blitter that we need to have. Y is always whatever that is, okay? So now, with this, we come to a formula, okay? Which is n, okay? Keeping also in mind that our screen is 320 pixels wide. That means whatever line we are in times 20, okay, we get the line number where we need to do our blit. Then whatever the pixel is, we need to divide the pixel number by 16 and add them together. This is for a 320 pixel screen. If the screen is not 320, then the formula changes a bit depending on the number of words that we have for that screen. Okay, so it is y times words per line, how many we have, plus x over 16. Okay, so it's the same formula here. We know that the width is 320, so we put 20 here, while here we don't know, and we need to know, and depending what that is, we add it there, but it's always the same formula. This is always starting from 0, okay? Just going up again. So here we are assuming that this value here is 0, but you know, the bit plane can be anywhere in memory, so we need to add the base address. So the formula changes a bit, which is address of bit plane plus n, okay, n is this calculation that we have here, and times 2. Why is that? N is times 2, because here we have it in words, but we need it in bytes, okay? So that's why n is times 2. The result that we have here, I forgot to say it, but I'm saying it now, this is words, okay? N is in words in this case, so that's why we have to multiply n by 2 and then add the base address to it. And we come to the next two examples regarding the blitter, and we are going to see now things happening on the screen. So let's jump to the Amiga. So I think I skipped one example. So this should be 9b1. I did 9b2. So when I press the left mouse button, we copy it from something from our program to the screen, okay? And I'm going to explain this now. So let's jump to the book and the examples book, and let me explain to you code. So as you see now, we are going to start using the examples, okay, using the startup file. Okay, the first part I didn't highlight, it's always the same. Okay, what we are interested in setting up the blitter and doing our blit. We are just copying one line, so you can guess what's going to happen. Before I do that, I'm going to show you, this is the data that we are copying from our memory to the screen. The screen is here, okay? You see bit plane. So the data is called figura a caso, whatever, just some imaginary image, some data. So before we start our blit, we always have to test that the blitter is free for us so that we can start setting it up. We are going to use, this is the mask, okay? He's saying that it's a mask channel here, but normally he says I will explain it later. Please assume the values here that this is what we need, okay? And assume, accept that they are f, a word of f, okay? For now. The min term, okay, and the channels, we are saying channel A and D again, and a min term of f0, okay? As I said, min terms, mask, whatever, they will all be explained later. Same as this channel, this register, blitcon1. For now, accept the values, what they are doing, and that it is a copy using channel A and channel D. So we are setting the address for channel A, and that is the so we pass the address, and we're setting the bit plane as destination. The bit plane address we are adding, okay, where we want to copy it. We are not copying it at the top right hand corner as you see on the Amiga, okay? I mean, the Amiga right now is a small screen, but you can tell it is not in the upper right hand corner where we're copying. We are copying in line 4, okay? So look, 4 times 20, and we did plus 32 over 16 times 2. So we are copying on line 4, okay, in position 32 pixels to the right, okay. So second word, okay, and we are multiplying by 2 because we need it in bytes. So we add the number of bytes that we have here to the bit plane, and we set the pointer. We are just copying 8 words, so of height 1. So 64 times 1 plus 8. That's the address that's the value that we need to move to the blit size. As soon as we do that, it starts copying and it copies that line. Okay? Nothing else. Once it finishes, we release it to the OS. That's basically it. I did another example which I will show you. Let's jump to the Amiga. It's the same example that we had with different data, just to show you that it is not something random that some Fabio just invented just like that. And I moved the data somewhere else. I put, instead of line 4, line 160, I believe, and that's where it moved it. I'm just going to show you that on the Amiga itself, where I'm showing that the calculation of the bit plane is, instead of 4, I replaced this with 160, and that moved the line further down from the bit plane base address, which is this address here. I believe we have another example to go through. Yes. So let's go to the continue on the Amiga. When we execute it, we are using the Blitter. Okay, so this is all done by the Blitter. We are copying the same line that we had before for 200 times. So on the bit plane. So the same line, the same data, okay, just copy it 200 times. Of course, this is slow the way it's done, but it is more to show the copying process more than anything else. So I'm going to explain it in the book now. So we shift to the book. So here we are specifying okay, that we are going to copy 200 times. It's -1 because we go to 0, so 0 to 199 is 200 times. Here is where we specify where we start at the bit plane address. So we start the bit plane address, so 80 is going to have the bit plane. We start at line 3, okay, so 3 times 20, and it is on the left hand side possible of line 3, so it has 0/16 times 2, okay, so we start from line 3 and exactly from the first word that line 3 has. This is our wait for raster line, okay, so we do the blit every frame, okay, so we copy one line one after the other. After we wait for our raster line at line 108, which is, I believe, is 264. 108, I think in hex is 264. So we wait for position 264 and then we do our blit. We make sure that the blitter has finished doing what it was doing, and then we set up our blitter. And here he said that the mask register, he's going to explain it at a later time, but this is the same value that we had before, the FFF for the mask register. Here this time, and notice we are not selecting channel A, but we are selecting channel B and D. This operation is being done, and the value you can see in BlitCon 0 is 5cc, which means we are using channel B and D, and we are using the min term that specifies a copy, let's say, just to keep it simple, and the value for that is 5cc. Then these three registers will be explained later, but one of them is BlitCon 1 and the other ones are the modulo for both registers. So for now, accept those values. Then we specify the source address from where we want to copy, and then the destination address, which is the address that we calculated in the beginning, okay, in this case here, where we want to start copying the first line. Of course, once we copy it, okay, we need to add 40 to 80 because remember our screen is 320 pixels. 320 pixels means 20 words for the blitter, but we are changing an address pointer, okay, where is the next address pointer on the bit plane, so that means it has to be in bytes, so we specify 40 and we do the loop. The 7 has got the number 200 or 199 that we have, and we copy it, we go through it 200 times through the loop. Of course, once we do the first blit and we loop, okay, we still need to check that the blitter has finished doing its copying, okay, so that needs to be always checked. Once we finish and we press the left mouse button, we can release it to the OS. Have faith in the blitter. Yes, Hound Dog, have faith. I mean, the registers, I cannot explain them all in one go. So, because there's not just me, Fabio, because there's many, we need to go through them one by one. And for now, we have to accept some of them as, as the default values. And as soon as we learn, we pass to the next one and next one. But yes, of course, I made another version of this one. So I'm going to go to the Amiga and show you my version, which is basically, I believe this one, I left it the same, but I changed the data. Okay. and I will show you. Yeah, I changed the date. As you can see, my bars are more solid, let's put it this way. And this is to show it is here. This is our figure, and this is the data that I changed from what we had in the book. In the book, I'm going to switch back to the book. So remember, F000 is the first one, then FF00. But once we jump to the book, you will see that here, figure, we had these values, not Fs. Okay, so that is just to show the values that I changed. We continue with the book. Now, we arrive to something that maybe you haven't thought about yet. So, I have shown you how to copy using the Blitter, but we were always copying one line. What if we want to copy more than one line? How do we do this? Okay, and this is what we are going to learn in the next section. How to specify more than one line. Our blits were always times 1, so 64 times 1 it was always. We never had 64 times 5 or times 10. And there's a reason for it. So, what do we know? Okay, first of all, let me read my notes to make sure that I don't skip anything. So let's start thinking of images that have a height of more than one line. Okay, we have said that the Blitter considers everything as a rectangle of words. Let's imagine that we want to copy an image that is 32 pixels by 2 lines. So what we have on the screen here. Okay, this image ends to be on the screen as shown on the diagram. So it has this block, okay, whatever it is. So the rectangle is of 2 words width and 2 words, sorry, not 2 words high, 2 lines I should write there. So I need to correct that one. Give me a second, guys. I'm going to correct it because that's a mistake from my side. Two lines, not 2 words. Okay, so that is 2 lines high. So what do we know from this diagram? What do we know? So we know that the first word starts in box or in word 21. The next one is next to it, which is 22. But then it's when we have a problem, okay? Because there's nothing else and we need to jump to the next line. So how do we tell the Blitter that we do not need to continue to copy and we need to jump to the next line? And to your I said all that. Funny enough, I'm really going. So if the next word is word 41, then the Blitter can skip from 23 to 40. Okay, so what he's saying here. So if we want, this is the last word, and we want to be here, the Blitter can skip from 23 to 40. Okay, how does the Blitter do that? This means that there are 18 words. The difference is of 18 words. Okay, we solve this problem by using our lovely modulo. Okay, that's how we tell the Blitter how many it needs to jump. So we tell the Blitter, hey, or we set the modulo, okay, to 18, and the Blitter will know once it does box number 22, it needs to jump 18. Okay, once it does this, it needs to do 18, and it will be the next word. This is why, okay, so now I explained the register that I was saying. We will explain it later, so we you can understand why we have the modulo. So here he gives another example where we have our bits, okay, that we are writing. Once we have written them, okay, we need to jump, okay, and then continue writing. How we calculate the modulo? Well, we know the width of our screen, no? So bit plane width in words, okay, so if our bit plane is 320, bytes is 40, words is 20. We know the width that we want to copy, okay, in this case it is 2 words, okay, so 20 minus 2 is 18, but the modulo is specified in bytes, so we do times 2, okay, hence why the formula and why I put it also in red, this needs to be written in bytes. So H represent bit plane width in words, L represent the words that we want to copy, so bit plane width in words minus blit width in words times 2, and we obtain the modulo. So we have already encountered the modulo for bit planes. In the case of the Blitter, it is specified the same. Okay, there is a difference in the way the modulo works for the Blitter, but I will come to that in a second. But in terms of specifying the size, it's the same. Okay, so same type of calculation. So it is possible to have different modulos for the 4 DMA channels. So each channel has got its own modulo. Okay, so you can specify a different modulo for each channel. This permits us to copy and shift between bit planes. Of course, if we can shift things with the modulo, then we can do certain things. The modulo is specified for the 4 registers. Each register has got an address where you specify the modulo. They are named BLT A or X, and X is replaced by the channel that you need, that you want, mod, okay, and they start from 060, 062, remember we start with C, 060, 062, 064, 066. So let's see what I've written in my notes. If we have an example, I mean, I didn't write it here, but just bear with me. If we have let's take an example, a rectangle that starts at line 13, word 6, so we move 6 words to the right from line 13, and then we do a length of 5 words that we want to copy. Okay, and we do this for more lines. Okay, this is calculated by having the 13 times 20 if the width is so to get the first address of this block. Okay, just to not to confuse you, let me show you the diagram. Okay, so if this was line 13, okay, we do 13 times 20, okay, times 2, okay, to get the address of this here plus the bit plane address. Okay, so we have the address of here plus the words that we need to shift, okay, to skip. So for our first address, so if we are skipping 6, then we do 6 times 2, okay, and that will be our first address. Then we do our two blits, our two words, not two blits, sorry, our two words, and then we do our modulo. So we, to calculate this, that paragraph was calculating this address here. Okay, so, and here he's actually, I forgot there's the diagram later, he is doing it at a much more, you can see it better here. So this corner here, okay, where I'm marking, is the address of our bit plane. Okay, so because it's on line 13, so we do 13 times 20 times 2 to get the address in to get the value in bytes, plus 12. You can see here what he did is 40, so this part he already did changed it into bytes, so 40 times 13 plus 12 plus the bit plane address. Okay, and hence this part alone is address 532. So this corner on the bit plane is offset from here 532 bytes, and then we add the address of the bit plane. So that is the bit plane pointer where we want to write. The modulo, we said there's 18 to the right, okay, 18 bytes, which is actually 9 words, okay, and there is 6 words, which is 12 bytes. So 12 plus 8, 18 is 30 bytes. So from here, once we write on line 13, once we write the first 2 words, sorry, the first 5 words in our case, because it's 5, we jump 30 bytes and we start at line 14 at this address. We are going to see something like that in this example 9C1. So sorry, let me go to the Amiga and we see this example. So this time, as you can see, we didn't copy one line, but multiple lines. You said me, hey, listen, but unfortunately, I'm not listening anything. So you can see that the image that we copied to the screen is not just one line. I'm going to explain this. So we jump to the book. Okay, so of course the initialization is always the same, so I'm not going to waste time on that. Now, this first example, we copy something to the screen from memory. So I'm going to show you, okay, what we copied, how it was defined. This is what we have defined in memory. You can see when there is a 1, it's 1 bit plane what we have, so it can only be on or off. So to colors, when there is a 1, we have the very good of the Amiga. So we copied this image to the screen, and this is of height 6 lines. So how did we do that? There's nothing else now. Okay, so the first two you have to accept, they are the mask and they are FFF for source and destination. In this case, we are going to use channel A and D. Again, because we're using A and D, you can see the 09 and then the midterm FO. Okay, so just accept that value. This time, BlitCon 1, I will explain it also later. Just accept that is at 0. Now we specify the module, okay, and this time it's not red. I explain what the module is, modulo is. So for the A register, for the A channel, okay, there's no, just to put it in perspective, once we copy it from here, there's nothing to skip. We just continue copying what we have under it, okay? So the modulo is 0, okay? So that is the source modulo. The destination modulo, okay, knowing that our image is towards, okay, and knowing that our screen width is 320 pixels, so 40 bytes, so 40 minus 4 bytes, because 2 words is 4 bytes, so the modulo becomes 36. So for the destination, we specify the module of 36, a module of 36. Here is our pointers. Here we say that the source address for channel A is where figura is, and the destination address is where bit plane is, okay? And we copy this at the upper left hand corner of the screen. We do not shift it anywhere yet, okay? I will come to a minute. Actually, I will come to it in the next stream. Now, this is where our first difference, okay? Because the image is 6 lines high, you can see it is 6 times 64, okay? And we said it is 2 words, so plus 2. So in Blit size, we wrote the rectangle of where the image of our image, how big it is. Hence 6 times 64 plus 2. Once we did that, it starts the copy process, okay? So this is where I finished yesterday with the stream. I hope that you liked what you saw today in relation to the Blitter. Please note, I am not finishing the modulo, okay? There is still 2 more examples related to the modulo, which I'm not doing, and I'm not doing them intentionally, because next week we will be doing shifting, and shifting is quite a long section, but I want to make the revision, so using those two examples that I left for the modulo, because the modulo will take is an important part for the Blitter, and hence it serves me to do a revision of the modulo before I go into shifting. I'd like to thank you very much for following me and hearing me. I hope you, as I said, you liked what I explained and that it was clear. Please come to Discord if you have any issues. I'm happy to help. Blitter is a long two long chapters. We just started. It's going to take a lot of time to finish Blitter. There's lots of discussions in relation to Blitter, but they are very interesting, and you will see lots of things that for now they look simple, but they will become more complex and complex. Thank you very much, guys. I hope you have a good week, okay, and see you next week. Thank you. Bye-bye. Bye. Bye-bye.